Right, we're going to graph 1 over x squared. Well, first thing you do is to test whether this function is rational or irrational. In order to do that, we need to find the degree of numerator polynomial and the degree of denominator polynomial. In this case, 1 is x to the power 0 and x squared is x to the power 2. And that implies that the degree of numerator polynomial is 0 and the degree of denominator polynomial is 2. And that indicates that this is bottom heavy and therefore it's rational function. Because it's rational, the condition on the top right also applies, so you can check that. The first thing we need to do is to find vertical asymptote. So the vertical asymptote is, what you do is set the denominator, which is x squared, equals to 0. And that implies that x is equal to 0. X equals to 0 is the imaginary vertical line of asymptote. We need to find the horizontal line of asymptote. In this case, because the degree of numerator polynomial is less than the degree of denominator polynomial, and therefore y is equal to 0. So y is always equal to 0 for rational function, always equal to 0. So that's the horizontal asymptote. Number 3, we need to find if there is a slant asymptote. Well, because this is a rational function, it will not be a slant asymptote. A slant asymptote only applies to irrational functions, so none. Number 4, we need to find a hole. Is there a hole in this function? Right, on the right hand side, you can see for there to be a hole in this function, it has to have common factor in both denominator and numerator, and there is no common factor in both numerator and denominator, and therefore there is no hole in this function, so none. Number 5, find y-intercept. Well, the y-intercept is when x equals to 0, what is y? As you can see, when x equals to 0 is the vertical line of asymptote, and therefore there is no interception in the y-axis. Number 6, find x-intercept. Again, to find the x-intercept, we always said when y equals to 0, what is x? Again, you can see that at y equals to 0 is the horizontal line of asymptote. There's no intercept on the x-axis. And 7 is to find the domain and the range. So to find the domain and the range, we do that once we've sketched the graph. Okay, now we can sketch the graph. Now I've got my axis drawn. I've got the y-axis and x-axis, and I've drawn the hidden lines, imaginary lines, when x equals to 0. So this line here is when x equals to 0, and the y-axis is when y equals to 0. So with this line drawn, I have decided now to sketch my graph. In order to sketch the graph, we know that we got 4 quadrants here, 4 parts in this graph. We need to know where our graph lies. And the way to do that is to basically try a couple of points. So what you do is you do x and y. So I want to find out where my first point will be. So to the right of the line x equals to 0, so I want to put x equals to 1. So to the right, I want to know where that point is, and to the left, I want to know where that point is. So when x equals to 1, what is y? When x is 1, y is, let's put it this way, y is y equals 1 over x squared. So when x is 1, you're going to get 1 over 1 squared, which is 1 over 1, which is 1. So y is 1. So when x is 1, y is 1. So if we look at the point here, if that was x equals 1 there, y would be 1 here too. So that's our first point. That's our point. So the first curve is in that region. We know it's not going to cross both y and x axis. So the curve will literally just go more like that and that. And that's what the curve will look like. And that's it for that part for the right hand side of the curve. And when x is minus 1, try when x is minus 1. Well, so okay, y equals to 1 over minus 1 squared. If you squared minus 1, you get 1. So that's 1 over 1, and therefore y equals 1. So when x is minus 1, y equals 1. Again, so here's minus 1 on this side of the graph. That's minus 1. And so that point will be there. So this curve, again, it's very similar. It's a reflection here. So you can see. And then just go. It's there. And therefore, this curve is a reflection along the x equals to 0. So that's a line of symmetry. The line of symmetry is the line when x equals to 0 because it's reflected along the y-axis. So that's the curve, the graph of 1 over x squared. And in this case, now we can find the domain and the range. Right, now that we've sketched the curve, we're going to look at the range and the domain and the range. First of all, just a reminder, the line of symmetry is when x equals to 0 because of a reflection of the two of the curves along the line y-axis. This line is the line where you said x equal to 0. So the domain is basically all the possible value for input x. So we start with x, start curly bracket, and then we do x colon. Now it starts from negative infinity along the x-axis, the red one, and then it goes all the way to x, all the way 0. So from negative infinity to 0 along the x-axis, and then they stop, there's a break obviously, and so therefore we close the bracket for that one, and we do union. U implies union, implies or, and then we do curly bracket again for x colon. 0 is less than x, and that's less than infinity, positive infinity, and close the curly bracket again. And that's your domain. The range, on the other hand, is from 0 to positive infinity. And that's where the curves are, from 0 to positive infinity. It never crosses 0. So therefore, we're going to do curly bracket, y colon, 0 is less than y, is less than plus infinity. And we close the curly bracket. And that's just the range. I hope you've enjoyed the sketching of 1 over x squared. Right, now that we've done 1 over x and 1 over x squared, I want to show you what happens when you stick a negative sign in front of a function. That function will be reflected over the x-axis. So, first of all, let's remind ourselves of the curves we get when we sketch 1 over x. So 1 over x is a curve that goes along all the way and approaches the line of asymptotes. Right, okay. And the line of asymptote is, in this case, x equals to 0, y equals to 0. Likewise, here it approaches the line of asymptote. For 1 over x squared is still the same as similar to 1 over x for the positive region of x, but all the negative region of x becomes positive because of the square, okay? And that's the graph for that one. If it's sketching, if you stick a minus sign in front of it, all the positive will become negative and all the negatives becomes positive. So that's what that would look like. And the same thing goes like that. And that's the curve for the negative version. For 1 over x, all the positive becomes negative and all the negatives become positive. Now that you've got those, the next thing to write down is the domain. So let's start with 1 over x. Positive 1 over x. Domain is all the positive value for x. So that's because we're describing the x-axis. So we write open curly bracket x because we're describing the x-axis. I'm going from minus infinity to 0, and then from 0 to plus infinity. So my description will be minus infinity, it's less than x, it's less than 0. Close the curly bracket. Union means or. Open the curly bracket. I'm going from describing x again still. I'm going from 0, less than x, less than positive infinity. Close the curly bracket. The range is very similar except you change x to y because you're going from negative infinity to 0 and from 0 to positive infinity. So the range would be similar except y. We're describing the y-axis for the range. minus infinity less than x, y, less than y, less than 0, union, open the curly bracket again, y colon 0 is less than y, is less than positive infinity. That's the domain there. Right. It'll be same for actually, so same for the domain of minus 1 over x and the r, the range. That will be the same basically. For the 1 over x squared, the domain describing the x-axis, as we know, x colon. Right, we're going from minus infinity to 0, then 0 to plus infinity. So we write minus infinity. It's always start from the left, and then less than x is less than 0. Close the open curly bracket. Union, because there's a break. So if there's a break, you use union. And then start with the curly bracket again. X colon. You start from 0 this time, and less than x, less than positive infinity, close the curly bracket. The range, on the other hand, we're only starting from 0 to positive infinity. So we go from y colon 0 is less than y, it's less than positive infinity. For the minus 1 over x squared, domain will be same, but the range will be slightly different because we're going from 0 to minus infinity. So it will be, we only start from negative to positive. So we go open the curly bracket, y colon minus infinity is less than y is less than 0. That's the range. Okay, thank you for that. Hope you enjoyed that.